So now we're going to take a look at what actually it means to have an inverse function in terms of a real world situation. We're going to focus on what it looks like when we interchange the input and the output. Because notice we've seen that the roles of input and output might not always be fixed if we're talking about the original function versus when we're talking about the inverse function. Let's illustrate what's going on here by taking a look at a certain situation. We're going to talk about what these phrases, what these expressions tell us. So here's an example. Suppose W equals J at X is the average daily quantity of water in pints required by an oak tree of height X feet. So before I go to the example, let's take a look and see here. We first of all have X, and X is going to be the height of the tree in feet, and W is the amount of the water in pints. So now if I take a look at the first example, it's asking what's meant by the following. 18 is J at 23. So notice inside the parentheses is the 23. So that's going to tell me that's 23 feet. And on the other side, the 18, that has the location of where the W is. So that's going to tell us the amount of water. So that's going to be pints. So what we've learned is 23-foot tree needs 18 pints of water. So just in a little different way, a tree that's 23 feet tall requires 18 pints of water each day. So now look at the inverse situation. I have 35 is J inverse at 27. When we look at the inverse, this tells us that the domain and range have now reversed. So this 27 is no longer the height of the tree in feet. This is actually now the amount of water. And the 35 is now the height. Remember that comes from our notation. Remember, we have something as an inverse. W is J at X. If I were to do the inverse, that would tell me X is J inverse of W. And so the input is now the water. So now what I know is I need that if I have 27 pints of water, that's going to be enough to water a tree that's 35 feet tall. And you'll notice if I go to my next page, you'll see a little bit of an explanation of this. So now we can say that a tree that's 35 feet tall requires 27 pints of water, or we could say if we have 27 pints of water, we can actually water a tree that's 35 feet tall. Let's take a look at a second example. Suppose P at T is the population of deer in hundreds in Jefferson County T years after 2000. So suppose I wanted to say, well, what does P at 3 give me? Notice I don't have P at 3 equals a number. Well, P at 3, what I know is the 3 is going to be, T, the inside is T, so this is years. So P at 3 is telling me in 3 years, what would I be getting? Well, the population of deer. So P at 3 is going to give me the population of deer in hundreds in Jefferson County in 2003. I just don't know how many deer that is, right? So P at 3 is going to give me the population because P at T gives me the population. I can almost go back to my sentence. P at 3 is equal to the population of deer in hundreds in Jefferson County. Well, I don't have T. I have 3 after 2000, so in 2003. But P inverse of 3 is going to tell me something different, right? The 3 is now no longer a T, no longer a time value, but it's now the opposite variable. This is now the population. So now our input is the population, our output is the time. So P inverse of 3 is going to be telling us the year, right? It's going to give us the output of a year when the population was 300. So now what happens on this one is we know the population is 300. The output of the function would be the year when that occurs.